continue with exercise 6.6. In this question it is given to us that ABCD is a parallelogram and we have to prove that sum of squares of the diagonals of a parallelogram is equal to sum of squares of all the sides. That is, AC is the diagonal and BD is the diagonal. So we have to prove that AC square plus BD square is equal to AB square plus BC square plus CD square plus DA square. Now there are two methods of doing it. One method is by using the result that we have proved in the fifth question. In the fifth question, we saw that if this is a triangle ABC and AD is the median, that is BD equal to DC, then we had proved that AB square plus AC square is equal to twice of the median square plus half of BC square. This is what we had proved in the fifth question. Here in the parallelogram, we know that the diagonals of a parallelogram bisect each other. So AO is equal to OC and BO equal to OD. So if we look at this triangle ABC, then BO is the median of the triangle. So if BO is the median of the triangle, then let us use this result. So we will obtain AB square plus BC square is equal to twice of median square. So twice of BO square plus half of this side square. So half of AC square. Similarly, if we look at this triangle ADC, in this DO is the median. So again we use the result and we obtain AD square plus CD square is equal to twice of DO square plus half of AC square. And then we will simply add the two equations and we'll get the result. So we get AB square plus BC square plus CD square plus DA square is equal to twice of BO square plus twice of DO square plus half AC square plus half AC square becomes AC square. Now BO can be written as half of BD because O is the midpoint of BD. So in place of BO, we write down half of BD whole square. Similarly, O is the midpoint of BD, so DO can also be written as half of BD whole square plus AC square. So this becomes 2 into 1 by 4 BD square plus 2 into 1 by 4 BD square plus AC square. 2 ones are 2 twos are 2 ones are 2 twos are. So we obtain half BD square plus half BD square, which is BD square plus AC square. And this is what we had to prove. But here we have used the result of the fifth question. And this is not a standard result. So let us do this with the help of construction. We will be proving it because this is 10th board and we do not know the examiner who would be checking your paper. So we should be on the safer side. Now let us do this question by the other method. Here we do a construction. We draw BM perpendicular to AC. And we can see that this is a right angle triangle ABM. So we apply Pythagoras theorem in right triangle ABM. So on applying Pythagoras theorem, we obtain AB square is equal to AM square plus BM square. This is what we obtain by Pythagoras theorem. Now from the figure we can see that AM can be written as AO plus OM. So in place of AM we write down AO plus OM whole square plus BM square. Now we simplify this by using the identity A plus B whole square, which is A square plus B square plus 2AB plus BM square as it is. So this is what we obtain. But From the figure, if we see OM square plus BM square, OM square plus BM square would be equal to BO square by Pythagoras theorem in this right angle triangle BOM. So in place of OM square plus BM square, we write down BO square and the remaining terms as it is. So this is what we obtain as AB square. Let this be equation number 1. Now over here we can see another right angle triangle. This is right triangle BMC. So over here also we apply Pythagoras theorem. So in right triangle BMC, when we apply Pythagoras theorem, we obtain BC square is equal to MC square plus BM square. This is what we obtain by Pythagoras theorem. Now MC can be written, as you can see from the figure, it can be written as OC minus OM. So MC we write it as OC minus OM whole square plus BM square. This is BC square. And now let us simplify this. We simplify this by using the identity A minus B whole square. So it is A square plus B square minus 2AB plus BM square. This is what we obtain. But OM square plus BM square, OM square plus BM square can be written as BO square. So we write this as OC square plus BO square minus twice of OC into OM. And let this be equation number 2. So in equation 1 we have found out the value of AB square. In equation 2 we have found out the value of BC square. Now let us simply add these two equations. Equation 1 plus equation 2 we do. So on adding these two equations we obtain AB square plus BC square is equal to, we get AO square plus BO square plus twice of AO into OM plus OC square plus OB square minus twice of OC into OM. This is what we obtain. Now since O is the midpoint of AC, so AO can be written as half of AC. So AO square becomes half of AC square plus BO square plus BO square is twice of BO square. Again BO can be written as half of BD because O is the midpoint of BD. So in place of BO we write down half of BD whole square. And then this is OC square. OC can be written as half of AC whole square because O is the midpoint of AC. Over here we have plus twice of AO into OM minus twice of OC into OM. But we know that O is the midpoint of AC, so AO is equal to OC. So these two terms will get cancelled since AO is equal to OC. So these two terms get cancelled. Now we simplify this. This becomes 1 by 4 AC square plus 2 into 1 by 4 BD square plus 1 by 4 AC square. 2 ones are 2 twos are. 1 by 4 AC square plus 1 by 4 AC square becomes half of AC square plus half of BD square. This is AB square plus BC square. So we have proved that AB square plus BC square is half of AC square plus half of BD square. After this, no need to prove it over here, you can write down similarly. If we take this triangle ADC, so we write down similarly we obtain AD square plus CD square is equal to half of AC square plus half of BD square. Now we simply add these two equations. This is equation number 3 and this is equation number 4. We will simply add the two equations and we will obtain the result. So let us add these two equations. Equation 3 plus equation 4. So we obtain AB square plus BC square plus CD square plus DA square is equal to half AC square plus half AC square becomes AC square, half BD square plus half BD square becomes BD square, and this is what we had to prove. In the next question, it is given to us that AB and CD are two chords of a circle which intersect each other at point P, and we have to prove that triangle APC is similar to triangle DPB and AP into PB is equal to CP into DP. So let us take these two triangles APC and DPB. Over here we see that angle 1 is equal to angle 2 because they are vertically opposite angles, and angle 3 is equal to angle 4 because these are angles in the same segment which we have studied already in class 9 in chapter circles, angles in the same segment. So these are angles in the same segment. So we can say that these two triangles, triangle APC is similar to triangle DPB by AA criteria of similarity. And if the triangles are similar, then definitely corresponding sides are proportional. So let us take the ratio of the sides. AP upon DP is equal to CP upon PB. This is what we obtain by CPST, and then we cross multiply, so we obtain AP into PB is equal to CP into DP, and these are the two things that we had to prove. In the next question, AB and CD are the chords of the circle which intersect each other at point P when produced. They intersect outside the circle. Then we have to prove that triangle PAC is similar to triangle PDB and PA into PB is equal to PC into PD. This is what we have to prove. Now if we look at the figure, then we can see that angle 1 plus angle 2, this is equal to 180 degrees because they form a linear pair. Angle PCA plus ACD, angle 1 plus angle 2 is 180 degrees. Also we can see that angle 2 plus angle 3 is 180 degrees. Why? Because ABCD is a cyclic quadrilateral. Cyclic quadrilateral means a quadrilateral whose all the four vertices lie on the circle is known as a cyclic quadrilateral. This we have already studied in class 9th, and we have also studied that the sum of opposite angles of a cyclic quadrilateral is 180 degrees. That is why angle 2 plus angle 3 is 180 degrees. Since ABCD is a cyclic quadrilateral, and we know that the sum of opposite angles of a cyclic quadrilateral is 180 degrees. Now from the above two equations, definitely we can see that the right hand sides are equal, so the left hand sides will also be equal. So from here angle 2 and angle 2 gets cancelled, and we obtain angle 1 is equal to angle 3. Let this be equation number 1. Now let us take these two triangles. We have to prove them to be similar. We have to take triangle PAC and triangle PDP. This is triangle PAC, the small triangle, and this is the big triangle PBD. Over here we see that this angle, angle P, is the common angle. So we write down angle P is equal to angle P as it is the common angle, and we have angle 1 is equal to angle 3. We have already proved this from equation 1. So therefore these two triangles are similar by AA criteria of similarity. And if the triangles are similar, definitely corresponding sides would be proportional. So let us take the ratio of the sides. So we take PA upon PD is equal to PC upon PB. PC upon PB by CPST. And then we simply cross multiply, we get the result. So on cross multiplication we get PA into PB is equal to PC into PD, and this is what we had to prove. In the next question, it is given to us that BD upon CD is equal to AB upon AC, and we have to prove that AD is the bisector of angle A. So we have to prove that angle 1 is equal to angle 2. This question is just the converse of the first question which we had done. In the first question it was given to us that AD is the bisector, and we had to prove that BD by CD is equal to AB by AC. So this is just the converse of that question. Now over here again we do a construction. We extend BA to a point P such that AP is equal to AC. This is the construction which we have done. Now in triangle APC, we have AP is equal to AC by the construction which we had done. So definitely angles opposite to equal sides will also be equal. So we obtain that angle 3 is equal to angle 4 because angles opposite to equal sides are equal. Let this be equation number 1. Now what is given to us? It is given to us that BD upon CD is equal to AB upon AC. This is given to us. But AC is equal to AP. So in place of AC we write down AP. So this gives us BD upon CD is equal to AB upon AP, because this is the construction which we have done. Now what does this mean? BD by CD is equal to AP by PA. So it means that AD is parallel to PC by converse of BPT. So this implies that we obtain AD is parallel to PC by converse of BPT. Now since these are the two parallel lines, so that is why we obtain that angle 2 is equal to angle 3. These are the two parallel lines and this is the transversal. So angle 2 is equal to angle 3 because they are alternate interior angles, and angle 1 is equal to angle 4 because they are corresponding angles. But from equation 1 we have already proved that angle 3 is equal to angle 4. So the right hand sides are equal. So this implies that the left hand side will also be equal, and we obtain that angle 1 is equal to angle 2, that is AD is the bisector of angle A. In the next question they are saying Nazima is fly fishing in a stream. The figure is given in the book. The tip of her fishing rod is 1.8 meters above the surface of water. So this is the surface of water. The tip of her fishing rod is 1.8 meters above this surface of water, and the fly at the end of the string rests on the water 3.6 meters away and 2.4 meters from a point directly under the tip of the rod. So this is the point which is directly under the tip of the rod. This distance is given to us as 2.4 meters. Assuming that her string is taut, how much string does she have out? This is one part of the question. There are two parts of this question. First let us solve this question. So this is the figure that we obtain. Over here we have to find out the length of the string that she has. So this is a right angle triangle. So in right triangle ABC we apply Pythagoras theorem. So we obtain AC square is equal to 1.8 square plus 2.4 square. This is what we obtained by Pythagoras theorem. Let us simplify this. So this comes out to be 3.24 plus 5.76, which comes out to be 9. So AC square is 9. So the length of the string, this length comes out to be 3 meters. This is what we had to find out in the first part of the question. Now they are saying, if she pulls the string at the rate of 5 centimeters per second, what will be the horizontal distance of the fly from her after 12 seconds? So over here, the speed with which she is pulling the string is 5 centimeters per second. Time given to us is 12 seconds. So the length of the string which is being pulled up would be speed into time, centimeters per second into seconds will give us centimeters. So that would be the length of the string which is being pulled up. So 5 into 12, which comes out to be 60 centimeters. Since all the other things are given to us in meters, so we can write this as 60 upon 100, that is 0.6 meters. This is the length of the string which is being pulled up. But earlier, what was the total length of the string which we had found out? 3 meters was outside, out of which she is pulling up the string from here. So now 0.6 meters is being pulled up. So length of the string which is left out, length of the string which is out is, total length was 3 meters minus out of which 0.6 meters is pulled up. So 2.4 meters of the string is left out over here. She has pulled up this. So only 2.4 meters is left. So now the next figure for this part would be like this. This is 1.8 meters and this length of the string which is out is 2.4 meters, and we have to find out this distance. So let us name this as triangle PQR, and again since it is a right angle triangle, so we can apply Pythagoras theorem in right triangle PQR. So we obtain 2.4 whole square is equal to 1.8 whole square plus QR square. So from here QR comes out to be, QR square comes out to be under root 2.52 or QR comes out to be under root 2.52. Now you know how to calculate the square root by long division. You have already studied in class 9. So this comes out to be nearly 1.59 meters. But this is not the answer. They are saying what is the distance from her, that is from Nazima. As you can see the figure in the book, Nazima is sitting over here. And this distance is 1.2 meters. This distance we have found out. This is 1.59 meters. So therefore the required distance would be equal to 1.59 plus 1.2, which comes out to be 2.79 meters. And this is what we had to